Hi, everybody. Welcome back. So last time we talked about how writing a good R project is often is can be analogous to writing a really good essay in English Comp. And I want to move on from this to talk about naming things and using the right words. So there's a Shakespeare quote here, like, "What's in a name? That which we call a rose, by any other word would smell as sweet." There's another word. There's another quote, and I think it was Mark Twain. He said, "The difference between the right word and the almost right word is like the difference between the lightning and the lightning bug." Now, if you don't know what a lightning bug is, it may be called a firefly where you're from or what you're used to. There's basically little tiny bugs, and at night when it's dusk, they have some like bioluminescent effect, and they can glow a little bit. So think about the lightning and lightning bug being three letters different in the English language. And in fact, they both have the word lightning in them. But the incredible luminescent power of a lightning bolt versus the mild little flickering, if you will, of this bioluminescent insect. That's what, and I believe it was Mark Twain, that was what he was getting at, that names are important, that words are important, that when you write, the words that you choose are very, very important. The same is true in code. Okay. There are rules for how we write English, there are rules for how we write code. And those rules for how we write code are so that other people can read our code and understand what we're trying to do. Okay. So, again, I want us to think about words and how important they are. Specifically, we're going to start with this example right here. You wouldn't write a sentence like this. All of these words smashed together, no spaces. Now, I understood what I wrote here because I wrote it. You wouldn't write a sentence like this. But is this easy to read? If I had made a spelling error, would it be easy to pick out the spelling error if I'm not using spaces? Probably not. It would probably be rather challenging. So don't write your code like that. I've seen people that they think that the amount of code on the screen, they're going to get charged $1 if they take up too much space on the screen or something. Like, no, that's ridiculous. The computer does not charge you money for using extra space. Let your code breathe. Like, let it kind of spread out where it's easy for people to see. What's super important here is that, yes, we write code for a computer to execute, but we write code for humans to understand. So computer can execute malformed like code that looks atrociously ugly. The computer doesn't care if it's pretty or not, but a human being that day or 6 months later, or some other human, you being a human, you are going to appreciate code that is easy on your eyes, easy to understand. The computer doesn't care, but you as human, you do. So take care of your code, take care of your eyes, take care of the eyes of other people. This is one of the things. Some people have called me petty for this, but it's not. It really isn't, because poorly formatted code hides errors and hides other problems. Whenever I'm interviewing a candidate, I usually make sure that I get a code example from them, and I will look at their code and I want to make sure that I can read it and say, okay, this makes sense. This is easy to read. This is easy to follow. It's nicely well formatted. It looks clean. It doesn't look just all over the place. It doesn't look all smashed together. And that's important to me because I know that code that is easy to clean, or that is clean, is easy to check for mistakes. It's just easier to look at. It's easier to build upon. It's easier to use than code. Yes, it may work. The computer doesn't care. Again, poorly formatted code, the computer usually doesn't care. There's a couple of examples where the computer does, like for instance, YAML. The computer does care about formatting in that case, but almost all the other times the computer does not care about formatting. But it's we humans who need that formatting done appropriately. So we've already mentioned the idea that everything in R is an object. And so there's commentary about whether or not R is a purely object-oriented language. It's not. If that means something to you, if the phrase object-oriented means something to you based on your training, we can talk about it after class. But if you have no idea what an object-oriented language is, don't worry about it. Just understand that everything in R is an object, even if R isn't a purely object-oriented language. And since everything in R is an object, that means that most of the time your objects are going to have names. So I want you to think about names as being a message, if you will, for other people, you and other people. So let's say that you're tasked with cleaning out the office refrigerator. And you open the office refrigerator and you know it smells awful because nobody takes care of their stuff. And you see something labeled, and it is labeled and it just says lunch. Okay. And then you see another label that says Dr. Felipe, and then it gives a date, and the date was just like 2 days ago, and it says, you know, lasagna al forno or something on there, whatever it is. So there's a lot more information in that label. So like, okay, well, who does it belong to? When did they put it in the refrigerator, and what is it supposed to be? Versus a label that just says lunch. Okay, if you're suspicious and you're looking to throw one of these two things out, which one are you going to throw out? The one that is better labeled, you know who it belongs to, you know that it's only 2 days old, and you know what is supposed to be in it, versus the container that literally just says lunch on it. You're going to toss out the container that just says lunch. You open it up and you're like, I have no idea what this is. Out. Okay, so think about that whenever you're writing your code. I see folks name an object stuff. That's the equivalent of naming food in the refrigerator lunch. Well, of course it's lunch. Nobody, I mean, nobody. What else would it be? Nuclear codes? No, it's lunch. It's in the lunch refrigerator. I mean, that's not a helpful name. That's like naming something X. Okay, what does X mean? All right. But if you look at something like this and you say, oh, my age underscore num, well, you say, okay, well, I think I know what this is. This is an object that's holding my age, and I'm not sure what num is, but maybe this means it's numeric. Or char for char. Dr. Odom had talked about these things called characters. Maybe this is a character vector and it's called my message. So that kind of tracks. Messages are usually characters. So these types of object names they have a lot of information. They're compact, but they're packed with information versus stuff. All right. Or I love this person to death, but I have a colleague who loves naming objects thingy one and thingy two. Those of you who know me personally may have a guess as to who my beloved colleague is. I do have a lot of respect, a lot of admiration, and a lot of love for this person. But whenever they write code where an object is named thingy, it makes me frustrated, very frustrated. Don't do that. Give your objects good names. Not only that, but give your objects names that adhere to a good naming convention. Okay, now what do we need? What do we mean by a naming convention? Well, we already seen one earlier where we used this thing called shish kebab case, and we connected a whole bunch of words in a Quarto document with dashes in the middle, and it was like sticking words on a skewer. Well, there's also the snake case, and that is we have all of the words lowercase and we connect them with an underscore. This is the standard naming convention for most of the tidyverse code. There's also another naming convention called camel case. Now, there's two different kinds of camel case. One is called upper camel case. The other is called lower camel case. And it's a question to mark. The question is whether or not this first letter is capitalized or not. So if this first letter is a capital letter, this is called upper camel case. If the first letter is not a capital letter, it's a lower camel case. There is another group of R users that uses the camel case syntax, upper and lower, and that's the Bioconductor project. So if you work with statistical genetics or genomics, proteomics, DNA methylation, bioinformatics, anything related to that, and you're using R, you've probably heard of something called the Bioconductor project. Their standard naming convention is to use either upper or lower camel case. Okay. Some years ago, the Google working group for R recommended that people use period case. They made a horrible mistake. You should not use period case in R or in Python. And that's because the period is actually interpreted as something. I will not explain what that is, but just understand that unlike other languages where it's completely okay to use period case, you should not use period case in R or Python because the period actually does something. Um, and so the period case you can use in some other languages, please do not use it in R. So my favorite personally is to use this camel case and then I append like the type of object, whatever it is. So if it's a data frame, it will be the name underscore DF. If it is a numeric, it'll be the name underscore NUM. If it's a character, it's the name underscore CHAR, something like that, so that I look quickly at the object just based on the name, and I see what is it and what kind of object it is. Now, obviously, this is my own personal preference. I do recommend that you do it, but this is not gospel. If you want to stick with a much more standard naming convention in just data science across the board, I'd go with snake case. If you know that you're going to end up doing more biological science, biomedical science related to bioinformatics and medical informatics, maybe go with camel case because this is what they use more in that field. But again, what's more important is that you don't do this. Do not mix naming conventions. Do not decide to use a naming convention for part of your code and then just toss it out for other parts of your code. Pick a naming convention and stick with it throughout all of your work. And this is one of the other things that for the projects in this class, you'll have a partners or you'll have a team. You need to agree ahead of time, like, okay, which naming convention are we using? Are we using snake case? Are we using camel case? Are we using the Dr. Odom's naming convention where it's a little bit of a mixture of camel case and then what kind of object it is? Whatever you use, that's fine, except for period case. Don't use period case. Just be consistent with it. Okay, it'll get you. It'll lend dividends later on. All right. So I've got some exercises right here. We're wrapping this video up, but I want you to take some time, read through these exercises, and work on these exercises. They are about naming things. There's an old school computer scientist, I believe the name of Phil Carlton, and he said that there's only two hard things in data science, and that's cache invalidation, which is a notoriously difficult problem, and then naming things. I have a colleague named Professor Raymond Belize, and he says that there's only two hard things in data science. There's cache invalidation, naming things, and off by one errors. So the joke is that 3 is off by 1 from 2. So even though we said there's two hard things, we've actually counted a third. That kind of comes up more than you might realize, especially whenever you're dealing with computer science where you think that you started counting at 1, but someone else started counting at 0, and then you end up where somebody has 100 samples, but another person has 101 samples, and so you're really close. Like just looking at the data, you're like, oh yeah, this works, but then you realize you're actually off by 1 integer or something like that. So it comes up, unfortunately, quite a lot. It's a little nefarious, but yes, the humor there is that we said there's two hard things, and then we gave a third, the third being the off by 1 error. So anyway, that'll be all for this video. We will see you again shortly.